and follow it around, then you see the Ring of Fire.
You do.
Yep,
You
you
absolutely
surely
do.
do.
We know that most of that stuff happens on the southwest side of the Arc of Fire.
Mm-hmm.
It does happen over in Argentina or in Peru and Chile, and that's the meteor I was just talking about that enhanced that area, that part of the arc, and causes earthquakes today. Lots of them.
Well, I wonder, and I'm gonna go way out there. Could this have any effect on what they call the Dragon's Triangle?
Oh, like for the Sea of China or something like that, or
I mean, it's right off of that. I mean, if we look at it, the Dragon's Triangle would be what, off of Okinawa, I believe, or in the China Sea, like you say, where China's really wanting it. You know, where everybody's fighting over it right now. As a matter of fact, that those islands right there.
Well, I think that's more due to the gravitational field of the Earth, because it's not uniform, and it's formed by swirling vortices of space, if you wish, or the fluid of space.
I understand.
And I think there may be as many as 12 of those sites equally spaced around the planet, north and south of the equator. But that's another discussion. That's on gravity.
Right.
And a paper which I've been working on and have let it be on the shelf because discovering Eden and Atlantis was such a lot of fun that it took me away from that technical paper. And
I bet.
Of course, technical papers are for a limited audience,
Right.
so they're not profitable. I have to do that on my own time.
Well, Stan, let me ask you this then. This impact would this be what may have knocked the Earth off the 90-degree axis?
Absolutely. I checked it out, and it did it. The angle is right. Everything is right. That's what tilted us.
Well, it's not just the Earth. The universe kind of a tilt to it too because of that. I mean, I'm talking about the solar system.
No, I don't think this.
Or maybe the orbital. Maybe the orbital.
System.
Yeah. Well, wouldn't that affect if the planet was rocked off its axis? Wouldn't that affect the?
Well,
the
here's the
planetary
thing.
bodies?
Here's the thing. The seabed and the continents that we see as land and bathymetry, the sea bottom. This does not go really deep. It's a thin skim or skin on the surface of the Earth. And there's at least one void shell, empty shell inside the Earth underneath this, and maybe more as you get toward the core where it's very dense. Because of this, when the meteor that hit here, I mean, I use standard NASA equations for meteor size, composition, velocity, speed, angle of entry, all that, to determine how many, tons or metric tons of megatons of Earth would be moved by an impact. And I did it for this, and I thought, well, now that's not enough energy to do that. Then I realized they were using the Earth as a solid ball with the current mass. Mm-hmm. But it's basically the same mass it was when the asteroid hit the Earth to cause the flood. Mm-hmm. But it slowed the Earth down. The Earth expanded and created these voids inside, which reduced gravity, believe it or not, because you're spreading the mass further out, and we're up on the surface of it. So the pull of gravity is not as strong here as it would have been lower down towards the center.
And as the Earth was knocked off its axis and became more of an egg shape because of centrifugal force, then that would have created drag on its rotation, right?
The teardrop shape is a function of how the planet was originally formed.
Okay.
That's another discussion, but it would have caused some aberration in that, and it would have sent shock waves around the planet and tidal waves for days. Huge things, which was this sweeping hot water flood. And when it says the fountains of the deep were broken up, in that magenta area at the beginning of that yellow area, when you strike the mantle and break the mantle apart, it only takes about a 5-mile indentation, and you have hit the Moho discontinuity, which has very briny, salty water, various salt compounds in it, and it has a temperature of about 400 degrees Fahrenheit even today, and it's only about 5 to 15 miles thick at any place that you test it around the planet. It's thicker under the mountains and thinner under the oceans. Anyway, that was what happened. It broke into that area and forced the hot water in the Moho to just spurt up through breaks in the ocean floor. And it didn't stop there. I mean, this pressure caused leaks in what's now the North Pacific up near Washington State. All these smokers, they call them today, were originally very active during that year period of the flood for Noah. Now, in your mind, picture some of the NASA videos where they show a huge meteor hitting the Earth and explodes out across the planet, and steam and clouds form around it. And that's because it's got a lot of heat energy in the impact, kinetic energy converted to heat. And in this Indian Ocean impact area, it would have vaporized quadrillions of cubic feet of water up into the atmosphere. Before this time, there was a shell of water. There was no rainbows because there was no exact cloud. It was just very dense vapor, which caused dew to form. That's how they had rain, was dew overnight when it cooled a bit. This impact ruined all that. It
shoved all the oceans into the atmosphere.
It did, and that's why you had 40 days and nights of rain, because it went up in the atmosphere, cooled suddenly, and you had hailstorms, and you had rain all over the planet.
Weather. Yeah, weather.
Yeah, definitely weather. Not normal climate for sure. So you have the breaking the fountains of the deep by this asteroid. You have the creation of the rain by the asteroid. You have the tsunami swells sweeping around the planet, from this impact. It wasn't just a rising flood level. It was sweeping tidal, or tsunamis would be better, I guess, term for it. And it swept people and things off the surface of wherever they were living. This was mighty. And it explains exactly what is in the Hebrew version of the flood of Noah and the story.
And it makes sense why the Lord designed the ark such as he did, because it would have been able to withstand one of those big waves.
Well, yeah, it was sealed on the upper decks.
Right.
You could shut it so that it won't capsize. It was too well designed for that. But still, the surges and the king waves and stuff like that might have washed the upper deck, on the top, but not sink it.
Right.
Just an amazing discovery. And then I said to myself, wait a minute. Plato wrote about Atlantis being destroyed by the gods, the god of gods, who had a meeting and was unhappy with Poseidon and his children,
and his son
Atlantis.
Yeah.
I wonder. Now, let me go back and look. I looked at Eden, and it was in the Ngoro Crater in northern Tanzania, and there's a straight path right down the Great East African Rift to the tip of Saudi Arabia. And I thought, suppose Atlantis was, in Arabia somewhere. I better look this up. So I started looking through Plato's account, and there were a couple of technical points about size of this or that he contradicted himself on, but I figured out how to correct them. Anyway, I found that he was describing not only a part of Saudi Arabia, he was discussing the island of Arabia. Not Saudi Arabia, the island of Arabia. If you go down to slide 9, have a look at it.
Yeah, I'm looking at it right now. That's the one I was looking at.
Okay, well, now you're ahead of me there. That's good. In his ancient Greek, which he has been translated by Jowett and various others with differing attitudes about how he was describing the size of Atlantis, one said that he said Atlantis was greater in extent than Libya and Asia Minor. Well, they were talking about ancient Libya, and its coastline went up and included Morocco. Asia Minor is where you see the white outline up there. And I checked the outline of the water flow. We can see the old riverbeds and the old seabeds. That's the orange line going all around there.
Right.
And it was at all of the Arabian Peninsula. It went down the it went down either the Jordan River Valley today. It went in northern Israel, where Israel joins the Lebanon above it,
right.
And it crossed through there just south of the Sea of Galilee, and then went down to the port of Eilat, and then down into the Red Sea. But it might also have deviated in northern Israel and gone through the left side of the Sinai Peninsula, because there's evidence that was separated from North Africa for a time. So I thought, right, okay, let's compare the coastlines now, because I did that first because I thought, how would the Egyptians and the Greeks, how would they have known how to measure the area of Libya and Asia Minor and Atlantis? They didn't have airplanes, they didn't have satellites. how could they know and measure the area? Now, they possibly could have. But I said that probably the most likely was that they went along sea coast and they measured that way the line of the sea coast. It could determine the length of the coast and hence the length.
Trigonometry, yeah.
Okay. Well, when you do that, the ancient Libyan coastline, the Asia Minor coastline, and the Atlantis coastline I've drawn there, they come within 100,000 miles of each other. And on 1.3 million, sorry, not million. Anyway, they come within like 2 to 5% of each other in length. So then I said, okay, let's go ahead and suppose it was area. So then I found the area of ancient Libya, the area of ancient Asia Minor, and the area of Saudi Arabia, and joined with the Lebanon and Syria, all those Gulf states. They came within 100,000 miles of each other on a 1.3 million square mile area. So I knew I had it. No matter which way you translate that, I had it. That was it. That was Atlantis. And after that, then things got interesting. Go to slide 10.
Okay.
Oh, actually, go to slide 11 again.
Okay.
Now, that's what it looked like at the time that Atlantis was still viable and before the flood and the destruction of it. You'll see, I've turned it on its side so you can see it better. The Persian Gulf was originally called the Atlantic. It was named after the first son of Poseidon, Atlas.
Atlas, yep.
And you see how it went on over into the Mediterranean. And everybody thought when he was speaking of the Straits of Hercules or the pillars or columns of Hercules, he called it both things, that he was speaking of the Rock of Gibraltar, that being the Strait of Hercules. And although it may have been in modern times to him, the real Straits of Hercules, or the real join between the Mediterranean Sea and the Atlantic Sea, was that little narrow space in there you see at the tip of that white arrow,
yep,
where today Turkey is bordering onto Syria. Now, I have other pictures of that. I don't know if I've got it on the site here. Let me just see if I put it down to the base there somewhere. Yes, I did. Go down to slide 24.
Okay.
Now, that's looking from the Mediterranean back toward where we were looking from the air. The original Atlantic Ocean is where those yellow arrows hit down into the blue there. And the Straits of Hercules were either the mountains on the Turkey side on the left and Syria on the right, or these narrow straits that link the Mediterranean over there on the right. You can see that.
Yeah.
But I think from the description of Plato, the one on the left, the Straits of Hercules, where you have these high mountains that seem to be cut by, I don't know, Zeus or somebody, they said slice these mountains to make the straits or the pillars of Hercules because they're big and powerful. I think that's where it is. And the Greeks, by the way, they used to have a seaport right in the middle of that, but it was dry land inland from there. But they actually chose the seaport. And today there's a restaurant there called the Atlantis Restaurant, believe it or not.
And if I'm correct, it's been a while since I've studied Atlantis, but Plato said that Atlantis was what, to the west of the Straits of Hercules? Is that right?
I don't know whether it was west or beyond or in front of. They're trying to, they argue about that, whether Atlantis was on the other side of the strait or on this side. And if he's telling the story from Egypt or if he's telling the story from Greece, either way, for Atlantis to be where I've shown it here, it would have to be beyond the Pillars of Hercules, which it is.
Right.
It's just on the other end of the Mediterranean, not on the Atlantic Ocean we know today.
Yeah.
And look, the water flows in here. I traced over that for days, using various techniques to find the outline of the water back in those days. And if you'll notice, this is something that's hard to explain for a moment, but I'll tell you what it is. You'll notice that where the blue water line is at the Straits of Hercules on the left, lower left, there where the mountains are, if you go into Google Earth, you'll notice that the cliff sides of those mountains are a different color. And you can go up about 1,600 to 1,700 feet before it starts into the unscarred mountain range. So what it says was that the sea was 1,600 to 1,700 feet higher at that time, at least. All right? Now, so you say, how can the sea have been that high, done that much and whatever? And the answer is very simple. When the asteroid hit, go to slide 10.
Okay.
When the asteroid hit where that blue circle is, around 2350 BC. It kicked a lot of stuff forward as it was moving from west to east, as we saw earlier, but it also made